Once again, welcome to my YouTube channel, Pearson and Excel International Maths. And please subscribe and, of course, share widely. And today I want us to discuss Pure Mathematics 2 Algebraic Methods, which is Chapter 1. And in this video, we're going to look at example 14, which expects us to find a range of k, or to show something that k ranges between 0 to 8 over 9 when the equation kx squared plus 3kx plus 2 is equals to 0, where k is a constant, has no real roots. It has no real roots. Prove that k satisfies the inequality from 0 to 8 over 9, both limits inclusive. It has no real roots. And of course, when a quadratic equation has no real roots, of course, the first thing to do is that we suspect the discriminant, which is b squared minus 4ac, is less than 0. Because for a function not to have any solution, then the discriminant part, which is b squared minus 4ac, which is retrieved from the quadratic formula, as we all know that this part of the equation, or this part of the formula, is supposed to be 0 when we have no real roots. And going back to the equation, of course, you can see our a is k, our b is 3k, and our c is a 2. Exactly. So we need to pick this and substitute here and find out, and rather say b squared, which is 3k squared, minus 4 times a times c, 4 times k times 2, which is 8k, is going to be less than 0. And this one is 9k squared minus 8k is less than 0 if we have no real roots, if this function has no real roots. And of course, you realize that k is common. Then we have 9k minus 8, which is less than 0. And if this is the situation, the two brackets, when we move them out, the product is 0, it means that k itself is less than 0, or 9k minus 8 is less than 0. And if this is true, then 9k is less than 8. 9 divided by 9 is give us a realization k is less than 8 over 9. And of course, when k itself is 0, we're supposed to prove that k is greater than or equals to 0, or k is less than 8 over 9. There is no inequality, just less than 8 over 9. The upper limit is not inclusive as per the question. And what does this mean? If you can easily plot this graph using this kind of an equation, you realize that the critical values are 0 and 8 over 9. Those are the critical values if you are to plot this graph. And now that you can see the value of k is positive, the value of k is positive, it means therefore we have a graph that is U-shaped. And this is the graph of y is equals to k, 9k minus 8. Now, let us go back to examining our equation, or our question. The equation kx squared plus 3kx plus 2 is 0, where k is a constant, has no real roots. Prove that k satisfies the inequality k greater than or equals to 0 and k is less than 8 over 9. That one is a very straightforward because we started by talking about our discriminant being less than 0 and we got the critical values. So our duty is now very simple. It's just to highlight the graph, highlight our graph where the solution or the values of y is less than 0, and it is just that part because we started by talking about a discriminant being less than 0. Remember, this is the line y is equals to 0. So every time that we go below that line, then y is less than 0, which satisfies this inequality. And you can see the values of x, which satisfies that region. It's a continuous region, and therefore our k happens to be greater than or equals to 0 and less than 8 over 9 for this particular situation to make sense. Hence shown. Hence shown. And that is just like it. Please make sure you follow me, subscribe and share widely so that we can walk this journey together. All right.